The next objective is there are various field scenario where the ground undulation is appear to be uneven, or it is kind of undulation. In that case, the positioning of each receiver is vary, and this will affect the misinterpretation of the VS profile. So for that, we have utilized this cross correlation tools, because it is giving the similarity between the nearby receivers in the time frequency, and we have utilized wavelet coherence analysis as well. So for that, we have used the finite element simulation, where first we have analyzed with the single layer model. Further, we have demonstrated the applicability of this approach with the multi-layer model. So these are the three undulations, heap 1, heap 2, and heap 3 we have adopted, which is representing the logarithmic variation in the topography. So heap 2 is representing the square polynomial, and heap 3 is representing the cubic polynomial. So from the literature, it is shown for the horizontal or flat surface, response which is recorded is analyzed in the frequency domain, and they are showing the attenuation law for this frequency range 700, 1500 Hz. So we have analyzed the wave field which we have recorded in the model to demonstrate how the phase is varying along the offset distance. So we have observed the attenuation law for horizontal for the flat surface. In case of the heap 1, heap 2, and heap 3, we have observed after the 12 number of geophones, the attenuation is showing the similar pattern. Before that, it is showing the different pattern. So it is indicating these response are affected by the these kind of undulations or respective topography of these undulations. Further, we have observed that the cross correlation in case of the flat surface is showing the attenuation. So here we have analyzed the horizontal and vertical component of the wave field. So here we can see the high decay in the cross correlation for the horizontal component of wave field, but vertical component is having the less attenuation, and the time lag is increasing linearly. So it will represent the homogeneity of the soil medium. In case of the horizontal component of wave field, this nonlinearity is not observed. So for the final analysis, we have used the vertical component of wave field. So for the flat surface, we have observed that the horizontal component of the wave field is showing the uniform variation, but the magnitude of phases are less as compared to which is observed in the vertical component of the wave field, and that uniformity is maintained in this time and frequency range. In case of heap, this cross correlation from the vertical component is following the respective topography, and time lag analysis is also showing the linear variation from the vertical component. Horizontal component is not showing the significant for the flat surface. So this cross correlation is just to see how the topographical variation is consistent with the respective topography. In the wavelet coherence analysis, we have seen there are significant variation, because in this heap 3, the positioning of these geophones are varying. Like for this geophone, the different phases are observed. For this, different phases are observed. For this location, the phases are significantly different. This is observed in case of the horizontal component of wave field as well as from the vertical. But in case of vertical component of wave field, the variation is slightly different as compared to this horizontal component, and the magnitude wise the phases are high for vertical component of wave field. We can also observe the minimum phase, like the non-zero phase also occurring at the frequency of the 17 Hz at heap 3. So similar observation we have done for heap 1 and heap 2. Here the dispersion comes from each condition is shown here. So here from the comparison, we can see for the horizontal cases, from 8 Hz to 50 Hz there is a non-dispersiveness, and as the nature of undulation is increasing, the lower frequency is also getting disturbed, and the homogeneity is observed at the higher frequency. So this minimum frequency we have also observed from the wavelet coherence analysis, and from fundamental mode, these are the minimum frequency which we have observed. So these two observations, fundamental modes and the wavelet coherence analysis, provided the criteria to select the minimum frequency range. So using this minimum frequency range, we have inverted and we have obtained the constant Vs profile. Here in this topographical undulations, heave 1 and heave 3 is having the similar positioning of the sources, so it is underestimated. In case of heave 2, it is overestimated. The outcome of single layer model is giving a criteria to what are the conditions where we need to adopt the overestimation or underestimation. In the 3-layer soil model, we have obtained these variations. So it will reveal the like what at the silo depth we need to include the less correction in the Vs. At the higher depth the correction will be high. So from these objectives we have seen that the Fourier amplitude spectrum depicted from this wave fields, showing the energy distribution of each receiver, maximum cross correlation coefficient of this receiver response aligned with the respective ground undulation. We have defined this frequency range based on the dispersion fundamental mode dispersion curve and the wavelet coherence analysis. The minimum frequency range is adopted to decide the effective frequency range of the fundamental mode, which is giving the nature of the medium.